Hi friends, we're going to do 2.6 scatter plots. So you have this in front of you, okay? So one of the first things with the scatter plot, let's take a notice. So this is average daily temperatures and beach visitors. So we're seeing as you increase in temperature, do more people go to the beach? And so you have plotted this. I want to point out some things on this graph. First of all, what is this little thing? Well, that means just a skip in numbers, which is fine. But I want you to notice that this is consistent. So this goes 80, 82, 84, 86, 88, it skips. This also goes up by 75. One of the hardest things for our students, I think, is when plotting a graph, making sure that see how this just really looks nice and it's spread throughout. We don't want all of our values down here. So you wanna take your time and really spread out the values. On your practice that you're going to be doing, it's temperature and ice cream sales. So you really need to take a look. I gave you some hints on what I think you should do for your values. And I really think you should take those serious because I think that's one of the hardest things. And then plotting points is not that hard, okay? But now we want to do our line of best fit. So here's our rules on line of best fit. We want to try to put, you know what, I'm going to go, I like my see-through rulers a little bit better. So when you put your line, we want to make sure to try to, number one, okay, misconception I hear students say is I try to make it go through zero. No, that is not what you want to do. What we're trying to do is get an idea of trying to split the line so that wherever I put my line, I have an equal number of points above the line and below. If you use a clear plastic, it surely helps a little bit. Let's see. So this would be 1, 2, 3, 4, 5. Man, that's an outlier. 1, 2, 3, 4, 5. 1, 2, 3, 4. About right there. I got these two below. What do you think about that? Or do you think I need to trend more this way? Because I have this weird one over here, which is weird, but I'm closer to most of the points here. How about that one? All right, I'm going to use the pencil and see what I've got here. Now, please notice that I really didn't talk about hitting the points, did I? I really could care less because you're going through a graph. So it really doesn't matter if you hit points. If you do, fantastic. If not, it's not a big deal. Okay. So I've got my trend line. It looks like, you know, I've tried to split the difference here and here. Yes, you can get that wrong if you don't split it properly, but I think I've done a pretty good job. Okay. And you can try it too. I ended up hitting these 3 points right here, but you can try it too because now the next step that I'm going to do is I'm going to come up with the line of best fit and all that. Before we get going on this, okay, we want to talk about what's the trend look like. So the first thing we're looking at the word is really the correlation. So we're going to be calculating an R value with our calculators. We can't really calculate it here because we can't calculate it right now by hand. We're not going to. But what does the correlation? Is this a positive correlation, a negative correlation, or none? Okay. Well, what line is this? Is this rising or falling? Right, it's rising. So this is really, we're looking at a positive correlation. Now, do I think it's like a super strong correlation? So here's our next choice. Is it strong or is it weak? Now, do you see the points? They're not all kind of clustered together, are they? So I would say this is more like, there's a trend, but it's not so great. Okay, it's okay. All right, our next step is to calculate the line of best fit by hand. So I need you to identify at just 2 points on the line that you're going to use to find your slope. So I'm going to use this one, and I'd like you to circle them on your graph. And I'm actually going to use this one up top. Okay, so this one here and this one. And I'd like you again to circle them so we can point them out. So let's write down our two values. Okay, notice I picked 2 points on the line. You can't pick 2 points to write the equation of the line that aren't on the line. So circle them, and then we're going to write them down. So let's see, this is 84, comma, 225. And what's this? 92, 94, and 600. All right, you know how to do this. X1, Y1, X2, Y2. Because I'm going to find my slope. So 600 minus 225 all over 94 minus 84. Now you have a calculator, use it. 600 minus 225 is 375 divided by 10. Well, that is 37.5. Okay, 37.5. Now, which point would you like to use to find your y-intercept? I'm going to use this one because I kind of like that 600 number. So here's my x and here's my y. Y is equal to mx plus b. So 600 equals 37.5 times 94 plus b. All right, so 37.5 times 94 is 3525. And this is 600 plus b. Subtract 3525. So 600 minus 3525 is negative 2925 equals b. Now that's really weird. Y equals 37.5 minus 29,025. Whoops, I forgot an X, didn't I? Okay. That's really weird. But keep in mind, you've kind of got some weird stuff going on in the graph. First of all, your temperature, okay? Second of all, you've skipped, okay? So this hopping below, it doesn't necessarily mean because of this that it wouldn't have went down a little bit farther. But what does 37.5 really mean for the slope? Well, for every degree, you really get 37.5 more people coming. Okay? Questions on that? Nothing new. Okay, the next part is going to be new. So I gave you a set of points here. Okay? We have our calculators. One of the first things I want you to do on your calculator is turn the diagnostic on. Okay, so here's what you need to do, and feel free to stop the video to have you do this. I need you to go to second function and go to catalog. Okay, and you'll get this whole bunch of, can you see those? Whole bunch of choices. You want to scroll down to diagnostic on. Okay, which is normally something that's not on. It's not going to throw you on or throw you off or anything. Diagnostic on, okay? Hit enter and hit enter again, okay? Diagnostic on. This will allow you to be able to calculate the correlation coefficient and also the correlation of determination, okay? So this is what we want to do. All right, in order to put in your values, you want to go to the button that says stat. So go to the stat button. All right, you're given in, it says edit, calc, or sort. So we want to go to edit because I want to put in list 1, list 2. I'm going to put in my values here. Now this set of data is the number of favorites. So this is a Facebook versus the number of posts. So they're trying to see if those that said favorites, if there's a correlation between the number of posts that you have. Okay, so these are going to be your X values. These are your Y values. So go ahead. What you do is you just type. Now I tend to type in all my X values first. So 36, 21. And I'm sure you'll be much faster than I am because you're so used to texting with those thumbs of yours. Okay, I'm coming back up to the top and I want to come over and put my Y values. Just double checking as you go along, making sure that the correct Y values go with the correct X values. Okay, I've listed all of my points. That took exceedingly less time than it would have had you graphed by hand. Okay, that's pretty crazy. Okay, now, if you want to see your graph, you have to turn on your stat plot. Okay, how you turn on your stat plot is you go to second function, okay, and hit this button, and it says plot off. You want to turn the plot on, okay? And then hopefully you have, so let's push this button, make sure there's no, oh, see, I already have a value in there. I'm going to clear that out so I can hit graph, because if there's anything in your Y equals, you're not going to stat plot. So, oh, that doesn't look very good. I wonder what's going on here. Oh, I have some pretty big numbers. This table only goes 10, this like 10 to negative 10, 10 to negative 10. So one of the things that I want to point out to you is, could you tell me, let's look on our X values. What is our lowest X value here? Looks like 2. Okay, so let's put our bottom number to 0. What's our highest? 95. So let's go 0 through 100. Okay. So here's what you're going to want to do. You want to go to this button right here. It says window. Okay. See how your values are negative 10 to 10. All right. So our X minimum, we're going to make it 0. And our maximum, we're going to make it 100. Okay. How's our Y values look? Well, our lowest is 0. All right, so let's keep our Y values at 0. But what's our highest? 46. Let's go up to 50. Okay. The reason I'm showing you this window trick is because I had kids ask me from the SAT that they couldn't see the graph, and that's because they hadn't adjusted their window. Oh, wow, look at that. That's amazing. Isn't that cool? All right. You know what would be even better? If it calculated the line of best fit. Wait, it will. Are you ready? Okay, so here's my scatter plot. Okay. Now, I want to go to stat again. So hit stat. See where it says calc? Go over to calc. So you get a whole bunch of choices. We want to do number 4. Number 4 is linear regression, okay? So to find line of best fit, we want to go to lin-reg, which is linear regression. That's like telling the calculator, hey, go and calculate this for me. So hit enter again. Oh, wow. So let's write this down. First of all, y is equal to ax plus b. Whoa, that sounds like mx plus b. Oh, it's the same thing. Awesome. So let's plug in our values. A is, let's do 2 decimal points, please. 4, 2, because 7, okay, x plus 1.22. Well, there's my line. Let's write down this r squared, and let's write down this r. So r squared is 0.89, and r is 0.9. Let's round it up to 5. Okay. So here's one more thing that we can do. Okay. I'm going to put y equals. Go back to your y equals button. Okay. Put in this formula, 0.42x plus 1.22. Sweet, sassy, molassy. Isn't that cool? So you can actually see how it hits all those points. How cool is that? That's pretty nice. Okay. And you didn't have to do any of the work with it. Now, what does this mean and what does this mean? Well, this R value, this is telling you your correlation, right? Remember, our choices for this are positive, negative, or neither. And remember, once we pick, so this is a positive 0.95. So this is positive, but this also tells you, is this a strong correlation? Is this pretty good? Or is this weak? Is it spread apart like our graph here? No, this is pretty good. 0.95 is pretty good. So your calculator calculated a strong positive correlation. That it looks like there's a strong positive correlation between the number of favorites that you have and the number of posts that you have. Okay? Now, what does this piece mean? This is called the correlation of determination. Okay? And what this really stands for is 80, you could say it in a statement, 89% of the data fits the trend. Okay. So what does that mean? 89% of our data will fit in this trend line. So the higher it is, the better your data. Okay. I know, excuse me, I know that you've done some different statistics where you've got outliers, okay, where you get some goofy number that's down here. This tells us that your data is closer together. That could be because you've surveyed a lot of people. The more people you survey, the less outliers you should get. But that would also mean the better your experiment has been designed. There's no extra outliers out there. When we give tests, if we have a class average of 86, but one kid gets a 15%, that's an outlier. And so then we're asking ourselves what's going on there. Do they have a wrong key? Did I use the wrong answer key? What's going on with the student? Okay. So you're going to be doing the same thing, but with another set of data with ice cream sales. You're going to do it by hand, and then you're going to do it on the calculator. Okay. All right. Have fun.